do simultaneously.
So download Ubuntu, you go 22 version or any version, like you go the website,
Okay.
download desktop Ubuntu. So here you can download this download release. Okay. So once you
Okay.
download this, so once you download this Ubuntu, and then you
Okay.
have to set up in the virtual box, there is a new machine you have to create. So like this,
Okay.
add a new machine, and then you have to give some name of the machine. Okay. And
Okay.
after that, you have to select the folder, this
Okay.
ISO. So this will be taking your default path of your user folder. It will create
Okay.
automatically this directory. This is ISO image, where your ISO image you downloaded. And after that, it will be asking username, password. So once
Okay.
you
What is ISO images?
this ISO image, like a what I say, like it's a kind of image copy.
Okay.
ISO is an image copy, right? It's like a Windows, we have exe thing is there, like we install
Yeah.
it.
Okay.
So ISO is like a complete Ubuntu software. Okay,
Okay.
complete Ubuntu software. So when you configure in VirtualBox, so everything will be stored in this ISO. Okay,
Okay.
so this ISO image size will keep increasing. Okay, because the initial size will be whatever you downloaded, and that is a basic operating system. In this ISO image, your base operating system means like basic features of operating system, like this Windows is there, right? Like whatever the feature comes in any operating system. Okay, so this
Okay.
is Ubuntu is a Linux, right? So you
Yeah.
will get a Linux desktop image. This is
Okay.
a basic Linux desktop image. Then if you install something, it will become your ISO will be increasing the size, right? Because you are keep downloading things, right? Okay.
Okay.
So like if you see my ISO, so I have configured in the VMware. Okay.
Okay.
So I have in VirtualBox also, in VMware also. So
Okay.
this is my VMware image. So VMware, I have configured my Ubuntu. So this is my desktop image, ISO,
Okay.
like after
Okay.
ISO. But when I'm installing Hadoop and everything, so same
Okay.
ISO image will size is increased. So my ISO file I show you, my desktop file, my Ubuntu file is C softwares here. So I
Mm-hmm.
kept it here in the Ubuntu. This is my ISO. So now this size is, initial size is 3.5 GB. Okay.
Okay.
But
Okay.
later on the size will increase because the same file is storing everything. Okay.
Yeah. Yeah. Okay. Got it.
So actually this is the ISO image, but its backup things is there in this folder. See users. You seen that one folder is created, right? Users,
Yeah.
my
Users.
username, and here virtual VM, virtual
Okay.
box VM. So here, whatever the this is additional, actually extra, like it is increasing like this.
Okay.
This is a
Whatever data
snapshot
we
of
are downloading in the middle of the work, that will be stored here.
yeah, whatever I am just doing anything installation, everything. So that is stored in this particular virtual VM
Okay.
folder. Okay.
Okay.
So virtual, actually, initially I given this software folder, this image, this is the original image, okay, which I downloaded from the Google 3.56, and it is exploded as a operating system in this folder, C users
Okay.
folder. It is exploded, right? And there is this users. So here is a users folder, and user folder is this folder, and this folder is having VirtualBox VM folder, and whatever Ubuntu, whatever name I given, so it is
Oh,
exploded over here. Okay. So now this size is becoming like 26 GB. Okay. So it will keep increasing. Okay. This size will
okay.
keep increasing. Okay. Whatever you are installing. Okay.
Okay.
So you can say this is your backup, right? Your
Yeah.
data, everything in this folder,
Okay.
okay.
Okay. Got it.
So this folder should not be deleted. If this is deleted, so nothing you can access. Okay.
Okay.
So everything is stored in the disk, right?
Okay.
In the Windows. Okay. So when I open my Ubuntu, so like it's like a same like a Windows, we have menus that they are terminals. So you once you come to your Ubuntu desktop, you
Mm.
can come to here and terminal, you can search terminal. Okay, you can come to here and then find terminal and you can add in the favorite. So your favorite will have your terminal. Okay.
Okay.
So like this, you can add the
Yeah,
things.
sure. I'll try
Okay.
to install today, and if I have any issues,
Yeah. Otherwise, I will do it. But Ubuntu thing is very easy. Okay.
yeah,
Ubuntu steps. I will give the video also, like how to install Ubuntu on
yeah,
VirtualBox. Okay.
yeah, sure.
Okay. So next thing is. So I finished the command, the Hadoop command. Okay.
Yeah,
So that is related to SDFS. Okay. So
yeah.
this all commands are the part of SDFS. Okay.
Okay.
So so SDFS is the Hadoop distributed file system. Okay. So first is like in the Hadoop, right? I say when I install Hadoop, Hadoop
Okay.
means automatically two things will come: SDFS and mapreduce. Okay. So mapreduce is the processing component and SDFS is the storage component. Okay. And SDFS again is divided into two parts: name node and data node. Name
Data
node
node.
and
Yeah.
data node. And mapreduce is further divided into two parts. What are the two parts? Resource manager and node manager. And so resource manager and node manager. Okay. So here is name node is master, data node is slave, resource manager is master, node manager is slave. So every machine having one data node and one node manager. Okay. Suppose I have a 20 node cluster. In this 20 node cluster, one machine has your name node, because name node is a master, so only one machine is required, and it is storing, name node is storing only metadata. It is storing metadata. Metadata is data about this data node. So how my Hadoop file system will come to know where my data is residing. So every information of data node is stored in the name node. So this name node machine is going down, so you can't access your cluster. Okay, but there is a concept of standby name node in Hadoop 2.x. So that is giving the backup of this name node. So this name node down, so standby name node will become active name node. Okay, so name node is containing the metadata and data node is a slave. All machines having the data node. Okay, so one machine has name node and all other 19 machines, all 19 machines.
You do things that's going to hinder. You can't have games all the time. If I can't support you, you don't have to support you.
Joseph, are you asking some question?
No, I'm sorry, sir.
Okay. Okay, so 19 machines have the data node copy, Okay, so all data nodes will be on the 19 machines. Like, and same thing is one machine, same name node machine has a job tracker, or it can be a different machine. So name node machine has job tracker. Okay, so name node machine has job tracker. Job tracker means resource manager. Okay, so resource manager. So this is only difference is Hadoop 1.x we call it job tracker, and Hadoop 2.x and 3.x newer version we call it resource manager. Okay, and other 19 machines, 19 machines have node manager.
Sir? So you said it's the source manager for the 3.2?
Yeah, 3.x, 3.2 or 2.x, any 2.x version. So they changed this name from 2.x onward. Okay, like 2.7, 2.8. So all okay, so all other like versions like 2.x, 2. Or 3.x, both are having resource manager and node manager. And before 2.x, the name is the resource manager is basically called job tracker, and this node manager is called task tracker. Okay.
Okay.
So, but they have added some more responsibility, the job tracker, and they call it resource manager, because resource manager is not only allocating the task to the node manager, it is managing the resources also, like queue and everything it is managing. Okay, that is the reason it is called resource manager, managing the resources. Okay, not only allocating task to the node manager. Okay, so that is a one task, like one job of resource manager is to assign the task to the node manager, but other than that it can manage the resources as well. Okay,
Okay.
so in
Thank
the
you.
MapReduce, now next thing is after the HDFS, like we have gone through storage component, right? So far, like what is storage and storage command, like HDFS command. Okay, so when I want to write a file to Hadoop file system, copy file, rename file, everything like we can do using the HDFS command. But next thing is like MapReduce. MapReduce is a processing component. Okay, so MapReduce is a processing component. So here we need to learn how to do the processing, right? How the Hadoop is doing the MapReduce processing using the MapReduce. So first thing is MapReduce is written in Java. Okay, so the code we write in MapReduce, it should be a Java code. It is Java or Python. The two ways we can write. But mainly the Java is preferred because Java is a distributed environment, we can use it. So MapReduce code is written Java, but nowadays nobody using MapReduce because one simple word count program you write, simple word count program takes 200 lines of code. Okay, in MapReduce in Java, MapReduce in Java. Same code if I write in Hive, if I say I want to write the code in Hive, so it should be only in Hive, it is a one line of code. Just select count start table, right? You write a query, select count start from table. That's it. So this is the very highly reduce the code. But sometimes I want to do customization, right? I want to write some custom functionality I want to write. So I cannot use the Hive. Hive is a SQL tool. Hive is a SQL tool. I will cover after MapReduce Hive only. So SQL data warehouse tool. SQL data warehouse tool. And MapReduce is processing Java component, okay, in Hadoop. So that is a difference. Okay, both are used for analytics. Okay, Hive is also used for analytics and MapReduce is also used for analytics. But MapReduce is a processing component, Java component in Hadoop. Okay, so nowadays MapReduce we are not using because it is more lines of code and the person should have the Java knowledge as well. But one thing is whatever you are learning in Hadoop, right? Either you learn Hive, Scoop, HBase, okay, Flume, everything is in the backend is MapReduce. Everything is generated as a MapReduce. Generated MapReduce. Okay, so MapReduce knowledge is important because if you want to understand how this Hive is converted in MapReduce, Scoop is converted into the MapReduce, HBase, Flume, so you should know the MapReduce concept. So in MapReduce concept, two part are there. One is map and second one is reduce. Okay, so this is like a design pattern or this is like a framework. So MapReduce is a framework, computing framework which has two functions. Okay, two functions. One is map and second one is reduce. Okay, so what is the concept of map and reduce? Suppose I say I have a text file. I just give us an example. I have some text file. I have some data. Okay, hello. I'm saying this is my text file is there. Suppose I'm saying this is my abc.txt. Some file is there. This is just example I'm taking. File could be a very large file. Okay, because Hadoop we are not using this kind of file. This file I can use it in Java, right? Because Java cannot do very large amount of data to process. That is the reason we are using Hadoop, right? So here I'm just taking an example. This file is having some line of text are there. How many lines are there? Total 3 lines are there. First line, second line, and third line. 3 lines are there in this text file. So I want to calculate a word count. So final output, what should be? What should be final output? Hello is coming 2 times, right? How is coming 2 times? R is coming 2 times. U is coming 2 times. Okay. I will say 1 time, M is a 1 time, and fine is a 1 time. This is my final output, right? I want to give input to my mapreduce program, this file, and I want to get the output from my mapreduce program, this output file. So this is also file, and I'm saying the name of this file is output.txt. Okay, so I have to give one input file and generate one output file. Okay, so how mapreduce can do efficiently? Okay, so suppose I'm giving my input to mapreduce program. So first, mapreduce program, what it will do. So mapreduce, I told you Java class is there, right? So 3 Java classes are there. One is a driver class. Second one is a mapper class. Third one is a reducer class. Okay, reducer class. So in driver class, this driver class is nothing but your main function. Java main function is there. From where our program will start. From where our execution will start. Execution will start. Like it is an entry point. Okay, entry point for our execution. Okay. Second one is mapper class. So whatever I was talking about, this map function, this mapper class has implementation of map function, and this reducer class is having your reduce function. Now we understand what is the map function and what is the reduce function. Okay, suppose I'm giving my input to driver class first, and driver class is calling the mapper class, and mapper class is calling reducer class. Again, control will go back to main class, and finally your program will be completed. Okay, so when I'm giving this input file, to the map function, so what will happen? So driver class doesn't do anything, it just call the mapper class map function. Okay, so when I call mapper class map function, so map function is splitting the data and giving each word one count, one count. Okay, so suppose I say I have 3 lines of text. I have these 2 lines. Suppose I have 3 lines are there. I'm fine. Okay, so one line will go to one mapper. So it will be distributing the data. What map function will do, it will distributing the data into multiple machine. Every machine has, I'm just taking an example. This all text is going to one machine. Okay, this first line is going to one machine, the second line is going to the one machine, and this going to the one machine. So I'm saying 3 mapper machines are there, and these 3 mapper machine having the different map function. So here is a one map function, here is also map function, because this mapreduce code is shipped, this mapreduce code is given to all machines. It is copied to all the machine. Okay, when we are starting our mapreduce program, your mapreduce program will copy all the machines. So your map function will be the same code. Your map function has the same code. So what map function will do, it will split the data, it is split by space, and each word is giving one count. Okay, so what will be the next thing from this? Hello, comma 1, right? This is a 1 key value pair. Second one is how, comma 1. This is 1 key value pair. R, comma 1 and U, comma 1. Okay, like this, it will create a key value pair. Same thing will happen here also, this machine, because this is also separate machine. So here individually, these all mapper task is running parallelly, because this mapper task is independent of this mapper task, because it is running parallelly. That is the reason it is running parallelly. There is no dependency. Okay, so how mapreduce program is faster? Because mapper task is running parallelly across the machines. That is the reason it is making it faster. Okay, because there is no dependency of this machine data, because our final output is word count. Okay, no matter which one is completed first. Okay, So this mapper machine, what will be the values? I is a one time, okay, M is a one time, and fine is a one time. This is all key value pair. After this, what will happen? There is a next phase is shuffle and sort. Okay, shuffle and sort is provided by the Hadoop framework. Okay, that is not defined here in our class. It is internally done by the Hadoop framework. What shuffle and sort will do? This mapper machine having the same word, this mapper machine, the first mapper machine has this word hello, and the same word is hello here also. So shuffling means the same word will come together. Finally, our end goal is whatever word is the same word, it should come together. So what shuffle and sort will do? It will first shuffling the data and then making it sorting, alphabetically sorting. So which one is the sorting wise which will come first? So hello comma, how many times hello is there? 2 times. So hello comma 1, right? This is the one pair. Second pair is how comma 1, 1. Okay. Third pair is r comma 1, 1, and then other one is I comma 1. This is only one value, I comma 1, and m comma 1, and fine comma 1. So like this pair, and in this one will be sorting also there. So which will come first? I or M? M will come first. So this pair will come first after the sorting. Okay. And then AR, alphabetically sorting order. So R will come, M, and then R, and then I. Okay, I, then fine, and then in hello E, HE, and then HO. Okay, so like this, it is making it sorting. So first shuffling is done from all the mapper, it will collect the data, aggregate, it will not do any sum, just it will bring the data. Okay, the final function is the reduce function. So this reduce function work is just make it aggregation sum. So final result, it will be preparing like this, m comma 1, r comma 2, okay, I comma 1, fine comma 1, because this is only one entry, hello comma 2. Okay, so the logic is written in this reduce function, making it counting like aggregation, and finally this how comma 2. And can you see this is our output? Like output will be like this only. It is not alphabetically, okay, but output will be like the same, like how, hello, how are you, two times, and I am and fine is one time. So here the logic is in mapreduce is map function is splitting the data in number of machines, and all mappers will be running parallelly. And what the mapper logic is splitting the data by delimited character. Okay, I will define what is my delimited character. So if I say my data is a comma separated like this, so I will give my delimited character comma, but my data is not separated by the comma, it is separated by space. So I will split by the space, and each word I have to give one count. So all mapper will be running parallelly and give each word as a one count. And next phase is shuffle and sort. So shuffle and sort phase is first is doing the shuffling, and then it will do the sorting. So all the word, all the key. So every phase you see key value pair is there. So here it is output is a key value pair, word comma 1. Here is output also key value pair, word comma 1, or word comma multiple values are there, right? So key and value. Again, final output of the reducer is also key comma value. So here is also output is key value pair we are getting. Okay. It's clear this one, mapreduce. I show you the image, so it will be more clear. I mean Java. So I will show the code, or I will run the code also. Okay. So okay, what is why we need MapReduce? So if I say in the traditional way, original, right? Suppose I have a very large amount of data is there. So first what I will do, my all machine are a separate machine. My all machines are separate machine. I will split my data. Suppose I have a 6 GB data. So I will make it 6 machine and 1 GB data. 1 GB data I will give it to all 6 machine. Okay. And each machine is doing its own matches. Each machine is doing on searching. Like we are searching the data, like we are finding the matches, like same word matches we are finding, and final count we are making it all matches, right? So in this traditional way, what is the disadvantage? The disadvantage is, like if I have a data is a large size, first of all I have to split manually. I have to split the data manually and load into separate machine, because it is not a distributed. And again, once my data is calculated, right, in each machine, then I have to concatenate all the result. I have to combine the result. So this manual activity is here. Here I'm splitting the data manually. I'm combining the data manually. But in Hadoop, if you see here, the map and reduce. So mapper is splitting the data automatically in number of machines, and reducer is aggregating the data automatically on number of machines, so that final output can be generated. Okay. So if you look at here, this one, suppose this is my input file. So this input file, every line is given to one machine. Okay. So again, it is a key value pair. So what is the key here? So value is this line of text is value, but key is the position of the line. So I assume it this line position is 0. And whatever the line of position of this one, how many number of characters are there in this line, the position will be of that number. Okay. Suppose I say it's a 4, 5, 4, 9, and 5, 14. So 14 comma this line of text, that is a key value pair. Okay. So it is like a memory address. This key is nothing but here offset. It is called offset, means a position where this line is start. Okay. And this key is where this line is start. And value is this particular line of text. And when it is given to the mapper, mapper is splitting the line and giving each word as a 1 count. And that is again key value pair. But here difference is here list of key and list of value. Okay. But when shuffling does, shuffling is making each word with list of values. And finally reducer is making it key with count of the value, whatever the count is there. Like here is 2, here is 3, here is 2, here is a 2. And that is my final output key value pair. So every step you see, your input is given key value pair. Here is a mapper output is a key value pair. Shuffle and sort is taking key value pair, but it is output is a key and list of value, again key value pair. And reducer is also having the output key value pair. So everything is in MapReduce is key and value. Okay. So key value is the input and output is also key value, right? Okay. So here, this is the MapReduce program. It's clear. Okay. So why MapReduce is faster? Okay. One reason I will tell you. Okay. Suppose I'm having a data in my database. Okay. Database has my data, right? And I'm writing some SQL query and getting the data from the database, Okay. Or another example is like, suppose I'm having some Java program. Okay. And I'm copying the data on every machine. Okay. So which one is, okay, suppose I say my data is very large. So which one is a good idea, right? I will copy the data to the program or program to copy the data. Okay. I have a 10 machine. Okay. And 10 machines. I have a 100 GB file is there. 100 GB file. This 100 GB file, one single file is there. One single file. Okay. This single file, I should ship it to the machines. That is easy, or my program, I should ship it to the data. So program is very small, right? My program is only KBs, right? My program is, this MapReduce program is hardly some KBs of size, right? I say 1000 KB, 1 MB. Okay. So this is a 1 MB program. So 1 MB program is easy to move, or you can say like 10 GB data you move to the machine, that is easy, right? So here in MapReduce is the concept of data localization. So data localization is like your data will remain at the same machine, right? Suppose I have 10 machines, so data will remain at their positions, their machines. You will not move the data. So 10 machines have this 1 GB data is there. So all one machine has 1 GB data. Okay. And now what you did, you copied your program of 1 MB, all these 10 machines. Okay. So suppose your file size is 10 GB, it is divided into 10 machine, 10 GBs, 1 GB on 10 machines. And who is doing this part? Hadoop framework is doing this one. We don't need to worry about how the distribution will happen. Just we will give this 10 GB file to the Hadoop framework, and Hadoop framework will divide this into 1 GB data, 1 GB data to each machine, and divide into 10 machine, So once the data is distributed, then we are copying our program, and this MapReduce program is running on the same machines. Okay. So here the data part is not moving at all. Data is remain at their position. Only program is going there on the data and processing it. Okay. And finally, the whatever output is needed, that will be collected. But our main data will not be moved anywhere. Okay. So this is called data localization, where in data localization, where your data is once provided, once stored on individual machine in MapReduce program, then program is copied to all machine where your data is residing. Machine where all, suppose you have a 100 node cluster, but whatever data you want to process, that is only 10 GB data. So your 10 machine are used, other 90 machines are not being used. So whatever machine have your data for your program, only those machine will process the data. Remaining machines will not be used, right? Okay. So all machines where your processing file data is stored, that only will be processed by MapReduce program. Okay. So whenever like any machine is needed to execute map function, it will execute the map. Otherwise, whenever it is needed to execute reduce function, it will execute the reduce function. So who will be giving this instruction? Resource manager is giving instruction, because resource manager is a computing part. So resource manager is giving instruction to node manager, instruction to node manager to process data on data node for that particular MapReduce program. Okay. So node manager will use the data which is available on that data node machine. Okay. So whatever, and who is giving instruction? Resource manager is giving instruction. It has to process. So this MapReduce program is completely driven by the resource manager only, because resource manager is providing the task to the node manager, and node manager is executing the task on the each data node machine. Okay. So I will show like this MapReduce program I want to execute also. So like this is a word count program. So this is a one single Java class. So in this word count program, one is a map. This is a map class. This is a one reduce class, and one is driver. This complete class is a driver. So here is this is a main function. So in this main function, we are creating a one job object, and this job object we are setting it. We are setting it like what is my mapper class, what is my reducer class, what is my output key class. So whatever we look at here, right? My key and value, right? So what is my output key, output value? Everything we can here in the diagram. Whatever we seen here, this is my output key. What is my output key here? This one. So output key and output value. What is input key, input value? This is my input key, input value. So what is the type of input key and what is the type of input value? What is the output key and what is the output value? So that is defined here in the job. Okay. So we need to set it. We need to set it output key, output value. Okay. Input key, input value, we don't need to set. Main is the output key, output value. And one more thing is whatever the data type you seen here, this text data type, this data type is a Hadoop data type. So we already know int type is there, double type is there, short type is there. But in Hadoop, these types are called serializable type. Text type, int writable. What is a serialization? Okay. We know, right, this process is not happening on one machine. This entire process is not happening on one machine. There are the multiple machines are there. So whenever your data is transferred over the machine, right? Now this machine is producing this output, but when this is shuffling is happening, then your data is shuffled from the different machine. Then your output of this machine will be converted into the byte array. Like byte array is a machine readable form. So once your data is converted machine readable form, that is basically serialization. And once it reaches to another machine, again it will be converted back to the original data. So that process is called deserialization. So serialization process is called when you're converting data to byte array and byte array to again original type, primitive type. So that is called your deserialization. Okay. So deserialization is the process of converting to byte array to original type. So here, when the data is transferred over the network, so Hadoop uses this kind of data type. So Hadoop uses like string type is called in Hadoop text type. Input is string type is called in Hadoop text type, and int is called in Hadoop is an int writable type. It's a serializable type. Okay. And if I'm using a double, so double writable is the class for double type. So every class has writable class. Okay. Like int has the int writable, double has the double writable, or float is having float writable, like this. But string has the text type. The string serializable class is text type. Okay. So when my program will start from here. It will create a one job object. It will create a it will set my main program class. What is my main program class? Word count, this class. So I'm setting my jar by class name, main class, and I will be setting the mapper class, reducer class, output key class, output value class. And what is the input type of my file? Input file type, that is a text type. My input file is output file is also text. Both are text type, so I'm giving input type and output type. And my program here, when I'm setting it like my mapper class name, right? Map.class. So it will call this class, mapper class. So in this class, this is a small class like this. So here, can you see the same code? I'm just reading the file and I'm just giving each word as a one count here, this logic. So here I'm splitting with the space. Okay, so here is I'm using tokenizer. So tokenizer is a one string class, like I can divided the word, okay, in number of words, a line into number of words, and each line I'm reading here, and line is divided into the number of words, and each word I'm giving as a like a value and the text, like whatever the key is there, and each word has a one count. And the reducer class is writing a logic for, okay, it's actually not coming completely correct. It is little complex to understanding point of view first time. Okay, but nobody will ask to write code, but at least for understanding point of view, where is a mapper and right reducer. So this thing is important. So any reducer code we are writing, okay, this symbol is not coming correctly. Yeah, here you can see. So when I'm writing, like suppose this is a word count is coming, right? So map class, extending mapper, separate class also you can write. Okay. So map class, extend mapper. Mapper is a API class, which is taking these two type is the input type. Long writable is a key and text is a value. And text comma int writable is output of map class. So first two parameter is the input and second two parameters are output type. And here, whatever I'm taking a line, I'm just writing the each word as a one count. So this one is nothing but your value one. This is a constant one, and this one is nothing but as a value one, right? So this is a mapper function. And what reducer is doing, reducer is taking input as a text comma int writable. If you have seen here, reducer is taking text comma int writable. So when reducer is taking input here, text comma, text is a key and int writable is a value. So reducer is taking a text is an input as a key and int writable is a list of values. Okay. So actually there is a one common variable is there, output, right? You can say here the collector, right? If you see in the code here, like in the mapper and reducer, how can share the data. So mapper and reducer can share the data by using this context, like one variable is their context. So same you can see in the reducer, same you have in the mapper also context. So whatever you write here in the context, same thing can be read by the reducer. And reducer is writing in the context, that will be given as a final output. Okay. So when the context we write it, so here they're saying the name is reporter. Okay. So when we write in the context, in mapper, so we can get from the reducer, we can get it. And then what we are doing here, we are getting the value, we are starting the value with 0 because we want to do the sum of the values. So how many values are coming? 1, 1, 1, 1, 1, like as many as number values are there, it will make it sum. And for the same key, whatever my key is there, for the same key, I will write in the my context key comma new int writable sum. Okay. So here is my final output is whatever the number of values are there in my list. So here suppose my values are, two values are there. So R is key and two values are there, my sum. So sum will be R comma 2. So this will be my final output value. Okay. So we have to write three classes. One is a driver. This is a driver code. One is a mapper. this one, and one is a reducer. Okay, so we can write 3 classes, or we can do like this. We can write only one single class, and there we can define the inner classes, like static classes are there. One is a map class, one is a reduce class, and this class itself is the driver class. Okay, so like this you can write a program in one single class, or you can write 3 separate classes. Like one is a mapper class separately, one mapper class, this one reducer class, and this is the driver class. And then we have to test the program in the editor. So this is clear somewhat, because mapreduce is having only this map and reduce logic. That's it. This is the main logic. Okay, so some more concept are there in mapreduce. There is a partitioner concept is there, combiner is there. Okay, so there are some more concept are there, but first of all need to understand this mapreduce logic. Okay, so I will give this link to understand more, like theoretically, like how this functionality is being done in the mapreduce. Okay, so I have to show the code. Okay, I have to run the code. Okay, so I will do one setup in IntelliJ. So what we need a one IntelliJ in our machine. Okay, so we need to download one editor. We need an editor to write a Java program in MapReduce. So we have to go to the website IntelliJ download. Okay, and here is a IntelliJ JBranch site. So here is the community version is there. This community version, you can download it. Okay, so in the Linux or Windows, little different to run. When you download this, you will get a one folder. Okay, so I have already done. So I show you, this is my IntelliJ folder. Softwares. And here is my IntelliJ folder. So like this folder, you will get it. When you download it, you will get it folder like this. When you download this and you extract it. And inside this, you go to the bin folder, and here you start the terminal, and here you have to run this idea.sh. Where is idea.sh? This one, idea.sh. So how to run /idea.sh. When you do this, it will start your IntelliJ. Okay, Windows, if you want to run, just we type it IntelliJ here. Like this, IntelliJ in Windows. So just click on this. So it is like a exe. So IntelliJ started here. So this is in the Windows. Okay. So this is in IntelliJ started. Okay. But if you are using Linux, right? So in Linux, okay, so this is like how to create a project. I will tell, I tell today now what is a Java program, how to create. But actual MapReduce code, I will write it tomorrow, but I'll show how to create a new Java project. We go to the file, new project, and here is an option, mav1 archetype. Okay, so here I have to give the project name. I say MapReduce word count, WC, MapReduce word count, and I select here archetype, mav1 archetype to start. Okay, and version is same, not a problem. And then I create a new project. And it is asking whether you want to create in this window or new window. I say this window. So it is creating one mav1 project, and mav1 project is having one pom.xml file. Okay. So we will get here the source folder. Here it will come source folder, and there we have to write our Java classes. Okay. And the two ways are run to Java MapReduce program. One is in IntelliJ we will run it, and the second one we will run on our Hadoop cluster. Okay. So here is SRC is coming. So here we have to add the Java classes. So this is my package, and here I can create a new Java class. So one class is a WC driver, my driver class. Okay, and this class is having the main function. So I will type main and main function. Okay, so this is my driver class. I can create in the same class all classes, or I can write separate classes. Okay, I will show both the ways. Okay, so we can copy paste this code there and then we can run. Okay, so I'll do one thing tomorrow. Show from the beginning, right? Like how to create. Just you install your IntelliJ. You download IntelliJ in Ubuntu, and once you download your Ubuntu, you have to go to your IntelliJ folder, okay, and bin folder, and there is the idea.sh. So you have to start on the terminal, right click on terminal, and then you can start /idea.sh. Like this, you can start your IntelliJ. Okay, once your IntelliJ is started, it is your editor, and there you can create your Java program. Okay, so here is in IntelliJ we can create some Java project, and we'll run it our mapreduce program over. Okay, anyone has question? Anything?
Yes. So for tomorrow, do we need to cover anything for tomorrow? Like tonight?
Tomorrow?
Yeah.
I'll give the code of this one, and I will give like my previous video also, so you can go through it, right? Okay, understand this mapreduce, all this concept of mapreduce. Okay, and just go through it, like same thing whatever I explained it today, right? This mapreduce program, same thing I have already explained. Yeah.
Yeah, it's definitely a learning curve, man, but you know, I'm ready to dive into it.
Yeah, it is a little not easy because this mapreduce is purely Java, and like a Java class concept, and these things should be clear. Like someone should know basic Java concept, like what is a program, what is a class, okay, and this APIs. This is completely Java code API. So whatever I showed here, this is completely Java API code. This
Yes,
is Java API.
Okay.
Okay. But this is just understanding of the concept, because nobody asked to write this kind of Java code. Nobody asked. But people wants to know whether you understand the MapReduce or not. What is, if suppose you know this, if you create this diagram, so you can easily explain someone like what is my input and what is a mapper, what is a shuffle, and what is a reduce, and what is my final output. So this is the logic everywhere. In complete Hadoop, the logic will remain same. The only thing is, in MapReduce, I'm creating my Java program. I'm creating my program myself. But for other component like Hive, Scoop, their Hadoop framework will create a MapReduce. Okay. So the advantage is like only MapReduce, we have to create our own custom code. But in other component on the behind, right behind like Hadoop is doing. Okay, we don't need to worry about that. Okay. So we have to write very minimal code. Only MapReduce is taking more number of lines of code, but the other like Spark you use, or you are using Spark, or you are using Hive, they are using hardly very less lines of code. Okay. So your code and product increase, right? When you are moving from MapReduce to other framework, your productivity will be increased. Okay. But understanding of the MapReduce is important, because everything is based on the MapReduce in other component. Okay.
Okay. Well, thank you.
Okay, fine. Yeah.
Have a nice day. I'll see you tomorrow.
Yeah, see you tomorrow.
Okay, thank you.
Okay, bye.